What the hell? Rechargeable 1.5 volt lithium AA's? What is that? If you find yourself asking that question, then you've come to the right place. If you're like me with a growing collection of all sorts of batteries to power all my gadgets, then you probably have come across these new 1.5 volt rechargeable lithium AA's. And like myself, you ask yourself, do I need that? There's 1.5 volt non-rechargeable lithium primaries that have been around forever, but rechargeable lithium AA is something new to me. Welcome, ladies and gents. So XTAR was kind enough to send me their 1.5 volt lithium batteries. They sent me the AA's and the AAA's, and they were kind enough to send me the 18650 lithium rechargeable batteries. But for today's video, I'm going to be concentrating on the 1.5 volts only. And they also sent me the required charger to charge these batteries because they require a specific 1.5 volt lithium charger like this one. You can't just charge them with any regular nickel metal hydride charger. So let's take a look at the spec sheets of these batteries. The AA batteries have a capacity of 2500 milliamp hours, while the AAA has a capacity of 1000 milliamp hours. And what's interesting about these batteries is that they have a battery management system, or BMS for short, which handles the conversion of the 4.2 volts of the lithium down to 1.5 volts, which is more typical of alkalines and nickel metal hydride batteries. And the BMS also handles the safety features of the batteries like over voltage, overcharge, over discharge, over current, short circuit, and over temperature. So this battery, or these batteries, are rated at 2 amps continuous discharge, which I will test later on. And the cutoff voltage is 1.1 volts. And I believe there's lights at the ends of these batteries once it reaches the low voltage cutoff. So the BMS is essentially a regulated buck driver, which you typically find in modern LED flashlights like these, which handles the conversion or the regulating of the light output, or try to maintain a consistent voltage output or consistent current. With the specs out of the way, let's go test out these batteries. And the way I'm going to do that is using these flashlights. These are the only things that I was able to use to test these batteries. And this one uses 3 AAA's. And this one uses a single AA's. To test the limits of these XTAR batteries, to see if it can reach the 2 amp current draw, I'll be measuring the current draw as well as the lumens output using this bulb head flashlight. Okay, here we go. Hopefully this works. So let's take a look at the runtime charts for these batteries. Looking at the AAA, which I used on the bulb head flashlight, which uses 3 AAA's, we can see it ran at 330 lumens output at 1 amps for about 40 minutes before dropping down to 120 lumens, which ran for another 40 minutes or so, with a total runtime of 1.5 hours before turning off. And unfortunately, I was not able to test this battery at 2 amps. It just wouldn't do it. I tried different days, different sessions, different ambient temperature. Right now it's winter, so it's in my room, it's 68 degrees Fahrenheit, which is pretty cool. And the battery just would not allow 2 amps. So if I ran the flashlight at 2 amps, which outputs about 600 lumens, it would run for about 4 minutes or so, sometimes less, sometimes more, depending on the temperature. And it would start blinking or cutting off the voltage or current. So I'm guessing the BMS, or battery management system, started kicking in when the temperature reached a high temperature, and the batteries did feel very hot. So that's what I'm guessing is what's happening. Compared to a nickel metal hydride battery, the Fujitsu AAA, the nickel metal hydride has a lower output but a longer runtime. You could see the trade-off between the 1.5 volt lithiums and a nickel metal hydride. So there's no free energy here. You either get a higher output, shorter runtime, or a lower output of the nickel metal hydrides, but a longer runtime. Let's take a look at the runtime for the AA batteries, which I used on the Coast flashlight, which uses a single AA battery. And we see that it ran at 120 lumens output at 1.4 amps for about an hour before stepping down to 30 lumens, and that ran for about another 2.5 hours before completely turning off. Unfortunately, I was not able to test the 2 amp max continuous discharge for the AA's. I didn't have any devices that can run at 2 amps using the AA's, so we could safely say that this battery, at least the AA, can run at least 1.4 amps continuous discharge. And looking at the runtime for the nickel metal hydride, we see once again it has a lower output and about the same runtime. So once again, we've come to the end and judgment time. What can I say about these batteries? Well, I can't say that I was overly impressed. I certainly wasn't disappointed. They certainly have their use for like these flashlights, which benefited from the higher output compared to running them with the nickel metal hydrides or alkalines, but they failed to run at 2 amps, which is unfortunate. So I'm guessing these batteries would be typically used in a medium current load like these flashlights. I also use them on this image stabilized binoculars, which uses 4 AA's, which ran fine. I also used the AA's on my telescope, which has a auto tracking tripod. TV remotes, they'll probably run just fine. These are low current, so it should be no problem. But you could also just use regular alkalines or nickel metal hydrides for these low current devices like remote controls or alarm clocks. There you have it. I really wish it ran at 2 amps, at least 2 amps, which would have given these flashlights an even more higher output. All right, I think that would do it. So until next time, I will see you.